am MS Devimani, working as an assistant professor in the Department of Mathematics, Erode Sengundar Engineering College. Now we are going to see discrete mathematics. In this discrete mathematics, first unit is logic and proofs. First we see the definition of proposition. A proposition or statement is a declarative sentence which is either true or false but not both. If a proposition is true, then its truth value is denoted by T. If a proposition is false, then its truth value is denoted by F. P, Q, R, S, etc. are used to denote propositions. Always we are using the capital letters to denote propositions. Now we see some examples of declarative sentence. First one is New Delhi is the capital of India. This statement is true. Then second one is 1 plus 6 equal to 7. This is also true. 100 divided by 10, that is equal to 11. This sentence is false. These are examples for propositions. The following statements are examples for not propositions. The first one is, what is the height of Himalaya? This sentence is interrogative sentence. This is an example for not a proposition. Then second one is, what a wonderful joke this is. This is exclamatory sentence. Then third one is, obey my order. This is command statement. Then x plus 5 equal to 3. This is neither true nor false. Depending upon the value of x, we say that this is true or false. So these sentences are not propositions. We cannot assign true or false value for these statements. Next one is the definition of connective. Connective is an operation which is used to connect two or more than two statements. It is also known as logical connectives or logical operators. The next statement is primary statement or atomic statement. A declarative sentence which cannot be further split up into simple sentences are called primary statements or atomic statement or primitive statements. Any statement which cannot be split into more than two statements, that is called primary statement or atomic statements. Now we see basic connectives in logic and proofs. First one is not. Not is that is negation. The symbol for negation is this. Then and. We say that and is conjunction. Conjunction is represented by this symbol. Then or, that is disjunction. Then if then is we say that conditional statement or implication statement. Then fifth one is if and only if or biconditional. Biconditional is denoted by this symbol. These are the basic connectives in logic and proofs. That is 5 connectives: not, and, or, if, then, if and only if. These are the basic connectives in logics. Then truth table. The truth table of a proposition is either true or false. The truth table is a table that shows that truth value of a compound proposition for all possible cases. First we see the truth table for negation. That is, if P equal to true, then negation P is false. If P is false, then negation P is true. That is, we denote the statement P. Today is Saturday. This is true. Then we say that negation P is today is not Saturday. Here we want only one proposition. For this negation, we have only one proposition, that is P. Then we denote P is 2 plus 3 equal to 5. Then negation P is 2 plus 3 not equal to 5. Then next is truth table for conjunction. Here we take two propositions P and Q. So we have 4 possible cases. Since the truth value is true and false, so we have 4 possible cases. First we take P and Q both are true. Then P conjunction Q is also true. Then P is true, Q is false. Then P conjunction Q is false. Then P is false, Q is true. Then P conjunction Q is false. then P and Q both are false, then P conjunction Q is also false. If both P and Q are true, then we have P conjunction Q is true. If both P and Q are false, then P conjunction Q is also false. Example, we take the proposition P, Pavitra passed the examination, and Q, Sudha passed the examination. Then we write P conjunction Q as Pavitra and Sudha passed the examination. Then second example is P, Subha went to her native place, and Q, Raji went to her native place. Then we write P conjunction Q as Subha and Raji went to their native place. And then third one is third example, we take P, that is the proposition P is 3 less than 5. This proposition is true. Then the proposition Q, that is 2 plus 3 equal to 6, this is false. Then P conjunction Q, 3 less than 5 and 2 less than 3 equal to 6, this is false statement. Next we see the truth table for disjunction. Here also we take two propositions P and Q. If both P and Q are true, then P disjunction Q is true. Then one of P and Q is true, then P disjunction Q is also true. Both P and Q are false, then we have P disjunction Q is false. If only one proposition is true, then we have P disjunction Q is true. If both P and Q are false, then only we have P disjunction Q is false. Example, we take P, Deepa passed the exam, that is true. Q, Kavita passed the exam, that is true. Then P disjunction Q is Deepa or Kavita passed the exam, that is true statement. Okay, in the same way the remaining examples. Then next one is fourth one is conditional statement. That is conditional statement is if then. Let P and Q are any two statements, then this is the truth table for conditional. If both P and Q are true, then P conditional Q is true, and also both P and Q are false, then P conditional Q is true. If P is true, Q is false, then P conditional Q is false. If P is false, Q is true, then P conditional Q is true. Okay, this is the truth table for conditional statement. The example is if we take P, that is 3 plus 6 equal to 10. This is the false statement. And Q, 2 plus 6 equal to 9. This is also false statement. Then P conditional Q, if 3 plus 6 equal to 10, then 2 plus 6 equal to 9. It is true statement. Then if we take the statement P or proposition P, it is hot. It is true statement. Then Q, 5 plus 3 equal to 6. It is false. Then we have P conditional Q is false. Next one is truth table for biconditional. We take P and Q are two propositions. If both P and Q are true and also both P and Q are false, then we have P biconditional Q is true. If one of P and Q is false, then we have P biconditional Q is false. Example, we take the proposition P, money can write the exam. This is true. Q, money pay the fees. It is true. P biconditional Q is money can write the exam if and only if money paying the fees. It is a true statement. Okay. Next we write the symbolic form of the following statement. Given that if we take P, Malathi is rich, then we take Q, Malathi is happy. Write in symbolic form as Malathi is poor but happy, then Malathi is rich or unhappy, then Malathi is neither rich nor happy. We write the symbolic form of the above statements. First we denote P, that is Malathi is rich. Then we write negation P, Malathi is poor. Q, Malathi is happy. Negation Q, Malathi is unhappy. The first statement is Malathi is poor but happy. We write the first statement as negation P conjunction Q. Then the second statement, Malathi is rich or unhappy, that is P disjunction negation Q. Then the third statement, Malathi is neither rich nor happy. Neither rich nor happy, so we write negation P disjunction negation Q. Translate the following sentence into logical expression. Here the statement is, Pavitra can access the internet from campus only if she is a computer science major or she is not a fresh girl. Here the connectives are only if, then or and not. First we denote P. Pavitra can access the internet from campus. And the statement Q as Pavitra is a computer science major, and the statement R as Pavitra is a fresh girl. And negation R is Pavitra is not a fresh girl. So the given statement can be written as P conditional Q disjunction negation R. Then the third statement is, write the logical expression for, if tigers have wings, then the earth travels round the sun. We write P, tigers have wings. It is false statement. Q, the earth travels round the sun. It is also false statement. Then P conditional Q. It is a true statement. Write the following statement in symbolic form. If either Ram takes calculus or Krishna takes sociology, then Sita will take English. Here we write P. Ram takes calculus, Q as Krishna takes sociology, then R as Sita takes English. So we write the symbolic form of the given statement as P disjunction Q conditional R. Okay, thank you. Remaining topics we see the next class.